In this segment, we're going to talk about how to build resources, or how to build kind of systems that work for other languages with an idea of cross-lingual learning. So if we have our techniques like syntactic parsers or part-of-speech taggers or whatever, and we have labeled data in another language, modulo handling some of the effects like morphology that we saw before, we can basically take those methods that we had and apply them to that new data annotated in that language and build a system. But labeling such data sets is very expensive. So one question we might ask is, how do we take the existing resources that we have from languages like English and transfer these to what we call low resource languages? So the idea here is that these languages might not have as many annotated data sets as something like English, but we still want to build effective systems for them. So maybe in English we have a whole bunch of part-of-speech data and a whole bunch of raw text. And then in Spanish, we have a much smaller amount of part-of-speech data, but we have an English-Spanish bitext, and we also have raw text in Spanish. We want to take this whole hodgepodge of resources and build a Spanish tagger. And we want to do better than just taking the Spanish part-of-speech data and training a tagger over that. The question is, how do we kind of leverage all these things in combination? And this, you could go imagine an even more extreme scenario for a language like Malagasy. We don't even have part-of-speech data here. Instead, what we want to do is just take the English data and some bitext and train a tagger in Malagasy purely from these resources. All right, so one of the ideas that's been proposed here is essentially leveraging word alignment. So if we have the sentence, I like it a lot, and the sentence in French, je l'aime beaucoup, then we've seen in machine translation that we can produce alignments between these two sentences. Then based on these alignments, one thing that we could do is tag the sentence in English and then project those tags into French. And so some of these tags, we can kind of easily project because they're just aligned to one word, and some of them we can't. Like beaucoup, for example, here. This is aligned to both a and lot, and so we maybe aren't quite sure actually what tag it should have here. And so the kind of rough idea here, though, is that this will give us annotated data in French. It may be kind of noisy annotation, but hey, if our English part-of-speech tagger is getting 97% accuracy, this is still better than having nothing on the French side, right? So again, the procedure here is we basically tag the English, we project across the bitext, and then we train the French tagger. And how does this do? It actually works pretty well. I'm not going to kind of go into a full dissection of the results here, but this approach can build taggers that are much better than unsupervised taggers in languages like French. And so, it also applies much more broadly, so it'll handle languages like Malagasy that we saw on the previous slide. So this is pretty nice in that it lets us leverage stuff that we already have in order to build resources for other languages. And we can extend the same kind of idea to parsing. So the obvious most tricky thing here is the fact that different languages might have pretty divergent syntax. And so there's been a lot of work, which I'm not showing and I'm not going to talk about, over the last, really the last decade, on how to come up with syntactic formalisms that work across different languages, part-of-speech tags and labels for parsers and things like that are kind of universal here. So, but assuming that we have some shared syntactic representation, one thing we can do is say, all right, we're going to just boil down all the sentences to their pos tags, and then train a parser over these pos tags in one language, and then directly apply it to a new language. So if you have the sentence, I like tomatoes, we're just going to look at the tags. So we've got a pronoun, a verb, and a noun. And we've got I like them, pronoun, verb, pronoun. And then we train a parser to take input that's just tags. And what can this parser learn? Well, this parser can learn things like verbs tend to be the heads of pronouns and nouns. All right. And now if we get a sentence in French, je les aime, pronoun, pronoun, verb. All right. This is not the kind of thing that our English parser will have seen before, right? But regardless, this kind of simple rule that this parser has learned is still going to produce the correct parse in this case. And so if we see enough examples of different languages, we should be able to train a parser that can kind of flexibly handle different situations here. And so that's what this multi-dir approach here is in the kind of second to last and fourth to last columns. Basically, we train on the language specified in each row. This is testing on the language specified in each row, training on a mix of other tree banks. And so the accuracies here are not great. It's getting like 61% dependency accuracy on this, even when it has access to gold part-of-speech tags. But I'll point out that this is significantly better than you would get with an unsupervised approach. And there's ways to make this better. This multi-proj approach basically has a way of actually learning a parser with lexical features in the target language using a more complex way of doing things. So what this shows is that we don't necessarily have to despair when we have languages that there's not annotated data for. Obviously, annotating data is a great way to build out new tools for that language, but we can also think about how to leverage the tools that we already have in combination with stuff from, these ideas from word alignment and build things like parsers and taggers that work in these new languages. That's the end of the segment.